So this is our quality control report. We are coming from Q5 that consists of Muhammad Afif, Stefanie Ghea, Adela Almira, Matheus Bimo, and Nidiar Nursukma. The product that we are using is herbal product, which is Jamu Kunyit Asam. Medium Enterprises is an SME that is producing a herbal drink in the form of both instant powder from organic herbal herbs. This Assam East is located in Surabaya, and the product can be obtained in central of Assam East in Mer, Surabaya. Variations of the product is red ginger and turmeric herbal drink, and also red ginger and tamarind herbal drink instant powder. It's both attribute and variables. For the variables, we are observing a volume per bottle and also the weight per bottle. And for the attribute, we are observing the bottle defect, bottle cap defect, and label. Moving on to quality control tools. This is the data of variables that consists of the data of volume and also the data of weight. And in statistical process control, SPC is basically a tool for offline quality control emphasized by Karo Ishikawa for measuring and controlling the process performance. In our observations, we are using control chart and histogram. This is the way how to calculate histogram by calculating the class number, the range, and also the class length. The output of histogram. We can see that from 30 data, the highest distribution of data is in the last class. However, the histogram still shows the distribution of the data is located in the center, around 500 milliliters. And the ideal value of this histogram is when the volume is located near 500 milliliters. And this is the control chart of volume. In the visual moving range control chart represents the process variability and the process mean. In this case, the process mean is to be set as in control according to the Western electric rule. However, in process variability, there are two distinct graphs that represents the process has a high variability, which is the process number 5 and also the process number 22. Therefore, an understandable cost is needed to prevent a high variation that is prone to create a defect in the variable of volume. In individuals moving range of weight, the process mean are also to be set as in control. However, there are approximately 5 points or 5 data that represent a high process variability, which is the data number 9, number 12, number 11, and number 14, and also number 26. In this case, another assignable cost is necessary to prevent the defect in the variable of weight. And in the non-conforming chart, we found that the accumulation on one trial of picking 3 products only result into maximally 1 defect. In this case, the process is to be set as in control because there is no point outside the upper control limit. And this is actually the rules that we are using, which is the rules of Shewhart control charts, which is sensitizing rules. We previously judged whether or not the process is to be set as in control or out of control according to this rule. And moving on to the process capability, the control chart data might be used to describe the capability of the process to produce jamu with the weight and volume relative to these specifications. Process capability uses upper USL and LSL and also a process standard deviation to find the process capability ratio, which are utilized to measure the percentage of processes that use up the specification. For volume, it is 0.68, and for the weight, it is 0.69. It is actually pretty low because, as can be seen in the table, that for an existing system, the recommended capability process is 1.33 for two-sided specification. For further analysis, a CP interval is made using the formulation in slide 20, using chi-square transformation divided by n-1 of the data. it is found that the CP interval is ranged in the 0.12 until 1.2, which is still below the recommended point. Hence, it can be derived that the existing process of making jamu is still not so good. According to the process capability, it focuses on the process uniformity. Moving on to this design of experiment, the volume itself, all of the F value in this case has a lower value as compared to the F critical. If F value is greater than F critical, it means that we reject the null hypothesis. So the factor is influencing the variables. In the first variables, all of the F values has less values as compared to F critical, which means that both pouring tool and also the worker has no influence to the volume, which is we are observing in the first variable. And in second variable, we see that the value of columns is actually greater than F critical. That means that there is an influence between the manipulation of workers to the weight of the observed object. And that is actually the conclusions of ANOVA that we are using in this Sanam experiment. According to previously mentioned data, we have several improvements and suggestions. And before that, these are the quality assurance, which is using organic raw materials, using pouring tools to prevent liquid spilling, and has a fixed ratio of liquid and solid raw materials composition, and last but not least is continuously using trusted supplier. And the improvement is firstly using precise volume measurement tools before pouring the liquid. Secondly is do a proper recruitment for worker. Thirdly is using the digital weight scales after pouring. And fourth, and last but not least, is make a specific standard operating procedure for every single job. Thank you for your attention. We are coming from Q5. Thank you.